Okay.
John F. Kennedy was born today.
Oh, there we go. Right.
Yeah, just a fact.
50 times 0.5 is 25. Are you recording, whoever it is? Sorry about the sniff. Okay, thanks. Okay, so 50 times 0.5 is equal to 25, right? Okay, so that's mu, and that's going to be pretty important for the rest of this whole sum. So mu is equal to 25. Okay, and the next thing I've got to figure out is what, Daniela?
Standard deviation.
Okay, and if I'm using a binomial, it's the square root of np times 1 minus p, which is, well, np we know is 25, and 1 minus p is 1 minus a half, which is 0.5, which should be 12, square root of 12.5, or 25 over 2. Let me just check, because if we get this wrong, yeah. Okay, so we have a normal distribution, okay, where mu is equal to 25. Okay, don't worry about that. I don't really worry about that too much. Okay, so these are my two important parameters. Okay, so now this becomes a normal distribution question. Okay, righty. Okay. Right. So now the question is, what's the probability that x is, what are we looking for, guys? At least 30 heads. Okay. So we're looking for the probability. Okay, I'm going to go over to the next page. Okay. Probability of at least 30 heads. Okay. So we're looking for the probability that x is in the binomial is greater than or equal to 30, right? Okay. And we've got sigma is the square root of 12.5, and mu was 25, right? Okay. So now we're going to, first of all, let's just draw a little thing, our binomial, our normal distribution table. Okay. And we're going to have our x scores, and mu is 25. Okay. Now we're looking for the probability that x is greater than or equal to 30. Now, in a normal question, okay, whether that's greater than or equal to or greater than doesn't matter, because the probability that x is equal to 30 is 0. Okay, but we're using an approximation, so we have to do this continuity correction. We want to include 30. It says at least 30 heads. So, well, first of all, where's 30? 30 is a bit to the right. So I'm going to have 30 over there, and then draw in a bar. Okay. So, and as I say, you're only doing this for this binomial approximation, right? So now, Daniela, in this case, do I want the 30 bar?
Yes.
Yes, I do. Okay, and the edges of each bar are comma 5, right? So my correction means I'm going to start, if I want to include the whole of this bar, the 30 bar, then I want this whole region over here, including the 30 bar. Okay? So what am I going to look for? The probability that x is greater than, now in a norm, this is the normal parameter, right? This was the binomial parameter over there. Okay? So the normal parameter, including the continuity correction, is going to be probability x is bigger than what? What we're going to use?
29, wait,
That's
yeah,
it.
29.5.
Yeah. Perfect. Okay. So, and now it doesn't matter if you put greater than or equal to, makes no difference, because now I'm kind of in normal language, and in normal language, greater than or greater than equal to doesn't matter, because the probability of x is 29.5 in normal language is 0. Okay. So now we have a simple normal, all the hard work's kind of been done now, and now we're back to kind of what we used to. So I've got my x scores. Okay. I'm going to have to find my z scores that go with it. Okay. Here z is 0. I'm going to have a positive z score. I've got to find the z score now for 29.5. So what's the formula we're going to use, Daniela? Z is equal to?
X minus mu over sigma.
Good. And X is 29,5 minus mu is 25 and sigma is always leave it in third form, guys. Don't round that off, eh? Sigma is the square root of 12,5. Okay? Right. Log that into your calculator. Daniela, have you got an answer for me?
Not yet.
Okay, don't worry. When you do, let me know. Whew. Sorry, guys. It's a bit chaotic this morning. I ran for too long. Okay. And what did you get?
1,27. How many decimal places?
Yes, yeah, 2 decimal. For Z scores, always 2 decimal places. You did right. Z is equal to 1,27. Okay, so this is my Z score. That goes with 29,5. So I've got 1,27. Okay. So now I need to go find the yellow area. But we've got to use the negative space, don't forget. And we're going to go find the green area. Okay. So to find the green area, I'm going to look up a Z score of 1,27. Let's go look that up. 1,27. 1,2 is over there. 7 is here. Did you get 0,398 as well?
Yes, sir.
Okay, 0,3980. Okay, right. So I've got this area here is 0,3980. Okay. So if you want to write something, you can say the probability that Z is less than 1,27 is 0,3980. You don't have to write that. I would accept just putting it on the diagram. So overall, okay, the probability, let's go back to the original question and just put our final answer, that you get at least 30 heads. In other words, the probability that X is greater than or equal to 30, okay, is going to be equal to, so the yellow region is going to be equal to 0,5 minus 0,3980. I'll check the answer with the memo now. 0.5 minus 0.3980, and you get 0,102. Let's see. We are dead right, Daniela. Thank you for your assistance. Okay. Quite a lot of work in these sums. Okay. Almost guaranteed to come up. So just remember the process. That's the most important thing. Okay. A reminder to those who aren't here, okay, that your 3 steps when you're using a normal approximation, okay, is NP must be bigger than 5, N1 minus P is bigger than 5. Then you've got to find mu using that, sigma using that, and then watch out for your continuity correction. Okay, those are the differences between your normal questions and your normal approximation of binomial. And the advantage of this, guys, is what? Okay, well, if I was using binomial and I had to figure out, I'm throwing 50 coins, and I want to figure out the probability of getting more than 30 heads, well, you'd have to use the binomial formula 20 times to work out 30, 31, 32, in fact, 21 times, 32, 33, 44, it'd be all day, okay? So that's why it's a pretty powerful tool in that respect, okay? Right, any volunteers? Am I going to pick on somebody? No volunteers? Kara, is jy hier? Of doen sy wiskunde? Sy doen wiskunde. Are you there, Kara?
Yes, sir.
Is jy daar?
Yes.
Goeiemôre, Kara. Hoe gaan dit?
I'm good, thanks. And how are you, sir?
I'm good. Are you proud that the sheep in our garden is now named Skara?
Yes, I'm very proud, sir.
Good. All right. Okay. Kara, you're going to work with me with number 2. Okay.
Mm.
So the next question says, what's the probability that you get more than 18 heads? Okay. So we're looking for probability. So we can't include 18. Okay. So I'm going to make a note to ourselves. Don't include 18. Okay. Right. So probability that x is bigger than 18. So what was mu again? Mu was, we don't have to go calculate that again. Mu was 25. Sigma was the square root of 12,5. Okay. So laat ons draw ons diagram. Is jy nie trots op my nie, Kara?
Baie trots.
Okay, dankie. Right, so we're going to have x is greater than 18. So let's put in our x scores. Okay, so we've got mu is sitting at 25. So 18 is links from 25. Let's just put it in there. Okay, there's an x score of 18. Now, because we're looking at a binomial approximation using normal, always draw in the bar. Okay. Right. Okay. And now we want to know the probability that x is bigger than 18. So, Kara, do I want the 18 bar in this or not?
No.
No. So I'm going to go to the right of the bar. So I don't want this little green patch here. So what's the x score we're going to use for the normal? Just to always the edges of the bar are comma 5, right? So
Okay.
so the area I want, sorry, where x is bigger than 18 is this yellow region here.
Yes.
Okay. And so I want that whole yellow region. I don't want the 18 bar. Okay. So I'm going to exclude the whole 18 bar. The edges of the bar always comma 5. So what we're going to use this as? The x score we're going to use is
18,5.
back yourself, 18,5. That's it. Okay. So we're going to use an x score of 18,5. Right. So now we've done the kind of the hard work, all the different work. And now the question just becomes a normal distribution question. Okay. We want to figure out in normal language, what's the probability that x is bigger than 18,5. Bigger than 18 was the binomial language. Okay, this is now our normal approximation. This is what we call our continuity correction. Okay, so what do we have to go find now, Cara?
The area.
First, before the area,
Z,
you're right. Z score, right. Z is equal to x minus mu over sigma. Okay, so we're going to get 18,5. And we should get a negative Z score because it's to the left of the mean, right? Okay, because we've got a Z score of 0 there. We're going to get a negative Z score. Okay. Right, these things take a while, eh? Sure. Okay. So I've got Z is equal to 18,5 minus 25 over sigma, and sigma is the square root of 12,5. And what are we going to get? 18.5 minus 25 over the square root of 12.5 equals, and we get, but it's a Z score, let's get it to 2 decimal places. I got negative 1,84. Did you get that? I don't know.
Yes, sir.
Okay, so Z is equal to negative 1,84. I just want to double check that we're not wasting our time. Yeah, we're right. Okay. So Z is equal to negative 1,4. So there's my Z score over here of negative 1,84. And now to figure out the area, okay, the whole yellow area, I'm going to go look up a Z score though of 1,84. And this area is 0,5 here. I'm going to look up 1,84. That's going to give me that. I'm going to go 0,5 plus that. So let's go try to find a Z score of 1.84. 1.84. 1.84. I got 0,4671. Did you get that?
Yes.
Okay.
Yes, sir.
So Okay, 0,4671 is that area there. Okay, so in other words, the probability that X, let's go back to our binomial language, is I get more than 18 heads. Okay, probability that X is more than 18 is going to be what? 0,5 plus 0,467, and it's going to be 0,967. Check if we're right. Ons is heeltemal korrek. Baie dankie, Kara. Kara, wil jy iemand nomineer? Sy wil nie. Okay. So guys, what I'm going to do now is, who's there? Our usual suspects there. Mara, are you there?
Yes, sir.
Ah, Mara. Okay, guys, these things are taking longer than I thought. So let's just do, I'm going to leave the rest of number one. You've got the idea. The starting point for me is the most important part of the sum. So I think let's just do, I don't want to keep you too long. We're just going to do, let's try do question 2. Okay. So we've done A1 and A2. Okay. If you want, you can go finish the others for homework. I would suggest it at some point. Now we're going to do number 2, and let's try get 1 and 3. Maybe we can do. Okay, and then we'll be done. If you need to go, guys, it's fine. You can go. The hardcore people can stay. Right. So let's have a look at question 2. So Myra, let's go through our process. First thing it says, we've got a normal 6-sided die is throwing 650 times. Okay, is it a binomial? It is. Why? Because there are only 2 outcomes. What are they? You get a 6 or you don't get a 6. Okay, so X is equal to the number of 6s. Number 2. X is equal to the number of 6s. Okay, and so P, what's the probability of getting a 6, Mara?
1/6.
Okay, and N, it's a binomial distribution, sorry, because they're independent, mutually exclusive, etc. P is 1/6, and N is how many times the event happens, and what's N going to be?
250.
Okay, there we go. Right. So that's the scenario we've got. We're throwing a dice 250 times. We've got time on our hands. They're in lockdown. They don't have school. Okay, or they're not at reading. Right. So P is equal to 1/6. N is equal to 250. Okay, and they're chucking this coin. And the first question is, do the conditions for normal approximation to the binomial hold? So what is my method for checking that, Myra? I look at 2 parameters.
N times P.
Okay, good. In other words, I'm looking at the mean for the binomial positive distribution. And it's going to be 250 times 1/6. Lob that into your calculator. And we get 250 times 1/6. Ka-ching. And it's 41, way over. 41,2. The value. Okay. 41, let's look at it as 2 decimal places. 41,67. Okay. Right, which is, what's the important thing though, is that it's bigger than 5, right? Okay, and then I have to check at the negative mean, the negative outcome mean, so it's going to be N1 minus P, okay, which is going to be 250 times 1 minus 1/6, which is 5/6. And that's going to definitely be way bigger. 250 times 5/6, and it's 208,3. Okay, which is bigger than 5. So this is a pretty good fit. Okay, right. So yes, can use normal. Okay, right. Blah blah blah. Then next question B. It says, using the normal approximation, find the following probabilities. Okay, so B number 1, we've got to get the probability of at least 56s. Okay, good morning, bro. Morning. All right, probability of at least 56s. Okay. So, Myra, what do I have to work out first, though?
The mean and the
Standard deviation. Okay, so
standard
now
deviation.
we want to turn this into a normal distribution question, right? We know we can. Now, so the first thing is, can I use a normal approximation? Now we want to turn it into a normal approximation. To do that, I've got to find mu. Okay, how do I find the mean of a binomial distribution? Mean is equal to NP, right? Okay, which we worked out over here. It's 250 times 1 over 6. And 250 times 1 over 6 is 41,67. Let's keep it at 2 decimal places. So that's going to be an important parameter, that we're going to use a mean of 41,67. Okay. All right. Okay. And then we need to find our standard deviation, right? And the formula, I have to check the formula. I can't remember where this is given. I think it is sigma is equal to NP times, sorry guys, NP times 1 minus P. Okay, so sigma is going to be the square root of NP. Where were we? N is equal to 250. Well, so it's going to be 250 times P, which was 1 over 6, times 1 minus P, which is 5 over 6. So it's going to be square root of 250 times, well, that'll be 5 over 36. 5 over 36. And you get 25 root 2. Leave it in that form, guys. 25 root 2 over 6. Okay. Let me just check it right. Did the rest of you get that? 25 root 2 over 6? Yeah.
Yes, sir.
Okay. Right. So now I've got the parameters that I need. Whew. Stuff takes ages to do. Now we've got to figure out, now we've got to take it into, so that's our sigma, a normal distribution question. So in this particular normal distribution question, we're looking for the probability that at least 56s. Okay, at least 56s. So Myra, do I want 50 to be included?
Yes.
Yes, we do. Okay, in binomial language, that's quite important. Makes no difference really in normal distribution language. So I want the probability that x is bigger than or equal to 50. That's in binomial notation. Okay, and so now if we draw a diagram of the normal curve, we've got mu sitting at, look at our x scores. Okay, I mean, a question like this is worth a lot of marks. Mu is equal to 41,67. Okay, if I'm looking at my x score, so with z score, that's 0. So 50 is going to be to the right of that. So there's 50. Now it's a binomial approximation we're doing, so we want to have that whole scenario with the bar. Okay, and the question is, Myra, do we want to include the 50 bar or not?
Yes.
Yes, we do. Okay, so we're looking for this area over here, and we're going to include the whole bar over there. Okay, so what I'm going to do, I'm going to have to find an x score. So I want the whole of that bar. So what's the x score we're going to use, Myra?
49.5.
Good. X is 49,5. Okay. So in binomial language, we wanted that, but in normal language, we're looking for the probability that x is, again, it doesn't matter now whether we say greater than or equal to, because at 49,5 it's 0. Okay, so whether you have that or that makes no difference. Okay, so that's what we're looking for. Okay, the probability that x is greater than 49,5. Okay, so I need, what's my next process?
Finding the z score.
Good. So z is equal to x minus mu over sigma. So it's going to be 49,5 minus 41,67 over sigma, and sigma was 25 root 2 over 6. Okay, so what are we going to have? Let's try to work that out. And 49.5 minus 41.67 and 25 root 2 over, whoa, that's all gone wrong. 25 root 2 divided by 6. What did you get, Mara? Did you get that? 1 comma?
Yeah, I got 1,33.
Ah, cool beans. Right, so z is equal to 1,33. Yep, we're right. Okay, so z is equal to 1,33. Okay, so now I've got my z score that goes with 49,5 is z is equal to 1,33. So we're going to go find the green area over here. Okay, by using our table, and this is tells you that z is less than. Okay, let's just go get it. Okay, we're looking for 1,33. 1,33, 1,3 is over there, 3 is over there. I got 0,4082. Did you get that?
Yes, sir.
Okay, so this area over here is 0,4082. Okay, and what are we looking for? The yellow area, right? So the probability of the final answer, then the probability that x is greater than equal to 49,5, okay, is going to be 0,5 minus 0,4082, which is equal to at least 50. I mean, it must be, I mean, you think about it, you're throwing a dice how many times? 250. And we were asking more than 56s. And 0.5 minus 0.4082. So you have got a probability of 0,0918. In other words, approximately 9,1% of getting more than at least 56s when you throw a dice 250 times. Well, isn't that nice to know? Right. Do you want to do one more, or are you done?
We can do one more.
Okay. Let's have a look. Okay, at question. Well, the start of question. Let's try question 3. Okay. If you want to go, as I said, guys, you can go. It is being recorded. Okay. Morgan. Thank you for your assistance, Myra. Morgan, should we try number 3?
Yeah.
Are you staying with us or are you going?
I'm saying.
Okay, good. Right. So, question 3 says a professional psychology body estimates that 32% of the students taking Psych 1, I don't know, maybe I'm being brave doing this, okay, are in favor of studying statistics as part of their studies. If this estimate is correct, what is the probability that at least 700 Psych 1 students out of a random sample of 2,000 will be in favor of studying statistics? And you read that and you think, well, what the frickin' block and dong. Okay, but we break it down and let's have a look at what we got. Okay, personally, I would say use a normal approximation, just to give you a bit of a clue where we're heading. Okay, so if the system, what is probably at least 700 students? Okay, so let's, first of all, we're going to have to define x here. Okay, what's x going to be? We're looking at the number of number of psych students wanting to take stats. There's no way it's that high. About 3% of psych students will want to take stats. Number of psych students want to take stats. Okay, so that's what X is. Okay, number of psych students who want to take stats. All right. And then what's the P going to be then equal to? P is the probability of them wanting to do whatever X is, okay? So what's P going to be in this case, Morgan? What's the probability of a psych student wanting to take stats?
I don't have the book.
Okay, 32%. Okay, so the probability is 32%, which is 0.32. Okay, right. And now in this question, and either they're going to take stats or they're not going to take stats, so it's binomial. Where the one takes stats, we assume doesn't affect the other. Okay, so P is equal to 0.32. What's N? N is the number of students that we're working with for the question. Blah, blah, blah. If this estimate is correct, what's the probability at least 500, 700 psych students out of a random sample of 2,000? So N is 2,000. Would you agree with that?
Yeah.
Okay. Okay, so N is equal to 2,000. I just want to check something. Okay, and P is 0.32. Dead right. Okay, so Morgan, what's the first thing now that we want to do? Okay, we can't go figure out. Okay, we want to know the probability. The ultimate question is, what's the probability that at least that X is greater than or equal to 700? If we're going to use binomial, okay, you'd have to work out the probability of getting 700 students, 701, 702, all the way up to 2,000, okay, to take the rest of your life, okay? So we're going to use a normal approximation, because binomial will just take too long, okay? Binomial will take forever. Okay, personally, I would always say to you, use a normal approximation, okay, because there's enough going on without having to worry about that. So the first thing I would ask in this question is, can you use a normal approximation? And the sample size is pretty large, so I'm almost guaranteed that you can. Okay, plus it'd be a bit of a lame question if you couldn't. Right, so Morgan, what's our process to figure, can I use a normal approximation?
You calculate NP.
Top of your game, Morgan, top of your game. NP is going to be equal to 2,000. And what does it have to be if we're going to use this?
Greater than 5.
Greater than 5, yeah. Okay, 2,000 times 0.32, which is going to be 640, which is way bigger than 5. Okay, and then we look at the negative mean, which is going to be, well, the mean of the not scenario. So it's N times 1 minus P, which will be 2,000 times 1 minus 0.32, which is going to be even bigger.
360.
What did you say? 1 minus
1360.
Yeah, I got that too, which is bigger than 5. Okay, so therefore you can use normal approximation, right? Okay, so that's kind of step 1. Can we use the thing? Step 2 is now I've got to turn it into a normal distribution sum, and to do that I need to figure out mu, and using my binomial data, and I need to figure out sigma. Okay, mu is equal to NP, which we've worked out already, which is 2,000 times 0.32, which is equal to 640. And the formula for standard deviation is the square root of NP times 1 minus P, which is going to be, well, NP is 640, 1 minus P and we get this. What did you get, Morgan?
8 square root 170 over 5.
Okay, let's have a look. Not that we don't trust you, Morgan. Yep, I got that too. 8 square root 170 over 5. Right, so now I have my parameters. Okay, I've got mu is equal to 640. Okay, and I have sigma is 170 over 5. Now we can deal with the action. Now I'm just going to go do a normal distribution question, but don't forget of your continuity correction. So I'm looking for, in binomial language, the probability that at least 700 students want to do stats. So X is greater than or equal to 700, and that's in binomial language. Okay. So if I draw start drawing your diagram, guys. If you draw your diagram, Okay. Let's have our x scores, and our mean is at 640. Is that right, eh?
Mhm.
Yeah, I mean at 640. And just double checking everything. 640. Yeah. Okay, and we want to know probability x is bigger than or equal to 700. So 700 is somewhere to the right. Okay. But now, because I'm doing a binomial approximation, you've got to draw that whole the bar thing. Just makes life a bit easier if you've got that. Morgan, in this case, do I want the bar or not?
Yes.
They said the probability that x is bigger than or equal to 700. So do I want the individual 700 bar or not?
Yes.
Yes, you do. Okay. So we want this area over here. Okay. Okay. So to the left of the bar is always going to be comma something, right? So what's the x score we're going to be working with?
6999.5.
Yep. That's it. 699,5 is what we're going to be using. Okay. So the probability that x is equal to bigger than 700 with our continuity correction becomes, what's the probability that x is greater than 699,5? Okay. Yep, we're dead on track. So now I'm going to have to get a z score. So z is equal to x minus mu over sigma, which is going to be 699,5 minus mu is 640 over sigma, which is 8 root 170 over 5.
Is equal to 2.85.
2,85. Thank you, Morgan. Okay, so we get a score of 2,85, and that is coincides with what the textbook says you should get. Okay, so I've got Z here is 2,85. So let's go find the green area.
It's
So go look up at
0.9781.
2,85. Let's double check. 2,8. What is 5 is here. 0,49781, did you say? Well done, Morgan. 0,49781. So that's this area over here. 0,49781. Okay. And then you're going to have to say the area we want in yellow. In other words, our final answer. The probability that more than 700 students, at least 700 students want to do stats is going to be what? 0,5 minus 0,49781.
0.00219.
00219.
Yes.
So approximately 0,0020 zeros.
Yes.
Yeah, you're right. So only, see, but this is why if any of you decide to do psych, you're going to be like a legend, because only the psych students all have nervous breakdowns because they all have to do a year of stats, and that's where they all drop out. And you actually just be like, right. So, all right, guys, I think these things take a lot longer than I estimated. I would, yeah, try to do the ones that we haven't done, especially number 4 and number 5. Okay. But are you kind of, Morgan, as a class spokesman, are you kind of vaguely getting what's going on here?
Yes, I am.
Okay. Cool bananas. All right, guys, I'm going to let you go for your nice cup of tea and coffee. And when's the maths? When do you do your maths test? Is it after tea or the last lesson? What lessons are they? 6 and 7?
I think it's the one.
It's before lunch. Okay. Cool bananas. All right, guys. Thank you very much.
Thank you,
Thanks,
sir.
sir. Thanks, sir.
Have a good day, and we'll see you on Monday. Some of you, most of you, I hope. Okay. I told my class that you guys have to come up with a dress-up theme for every day. I mean, if we're going to be like in Corona scenario, we may as well have fun. All right, guys. Have a good one.
Thanks, sir. You too.
Thank you.
Bye.
Bye.